Right, so number 9 asks why steam at 100 degrees Celsius causes more serious burns than liquid at the same temperature. And this might seem a little bit strange, but there's actually more energy in the 100-degree steam than the 100-degree water. So I'm going to do this one with you. There's more energy. And the reason for that is that the steam actually gained more energy during the phase change. So you have to put energy into the water to get it to go from liquid to gas. And that extra energy actually causes the steam to cause a more serious burn than the liquid. The final question is a pretty lengthy calculation. And we're going to just do this whole one together. So in Chem 1, we learned about heating curves, and they are something that looks like this. And down here we have step 1, and this is when we have solid, and in this case it's ice. So the first thing you have to do is you have to add heat to melt the ice. Then you have to heat the liquid. And then you have to put energy in, and this would be part 2. And then you have to put energy in to change the liquid to gas. And that will be, and actually this is a phase change, it's solid to liquid. I should clarify that. And this is another phase change. This is where you go from liquid to gas. So you actually have both phases present at that time. So at part 1, actually all 3 parts you're going to solve for Q. And remember we said that was heat. Part 1 is called, you use something called the heat of fusion. And so the heat needed to go through this phase change is equal to the mass of the substance times the heat of fusion, which is unique for every substance. And this is going to be the heat of fusion of ice or water, and we see that's 334. We also see that we're working with 20 grams of ice. So we have 20 grams times 334, and those units are joules over grams. It's nice to put the units in because your grams will cancel, and then you know that you just have joules, which is a good unit for Q, or heat. When I multiplied those out, I got 6,680 joules. Then we have part 2. And part 2 is probably the equation we've used more. It's the mass times C times delta T. And we said that C is the specific heat capacity. And it's also unique for every substance. We still have 20 grams, so our mass has not changed. It's going to be the same throughout the whole problem. We now have water, and the specific heat of water is 4.18. And those units are joules over grams degrees Celsius. And then delta T. And you may be thinking that they don't give us enough information, but they actually do. So we know that ice is at 0. And we know that they're heating it all the way to steam at 100. So we've got a delta T of 0 to 100, which would be 100 Celsius degrees. And so cancel out all the units that you can. You know you're doing it right if you get joules for your unit that's left over. 20 times 4.18 times 100 is 8,360 joules. And then finally part 3 is the energy required to change the liquid water to a gas. So we're back to an equation that looks a lot like number 1. It's going to be M, and this time this one's called heat of vaporization, not heat of fusion, because we're going through a different phase change. So the mass still 20 grams through the whole thing. The heat of vaporization is 2,260. And when I multiply those, I got 45,200 joules. They do ask for the total quantity of heat. There are 3 different parts, so all you have to do is add all these up together. So this part plus this part plus this part, that is your answer. I'll let you all do that part on your own. Make sure you put unit of joules, and you should be done with your lab report. It's very important that you turn this in on Friday. I'm going to come in after school, collect them, grade them, put them in the computer for Dr. Peralta. But I don't necessarily want you to turn it in on Thursday because you have your quiz on Friday. Hope this made sense.